Welcome and good morning, ladies and gentlemen, to the technical forum of our group exhibit, Hydrogen Fuel Cells and Batteries. We will have a program today again of very interesting presentations here in our technical forum. And I'm very happy to have Dr. Arnstein Norheim here with us, Senior Engineer at ZEG Power AS, and he will talk about highly efficient hydrogen and power production from gas without CO2 emissions. Please welcome with me Dr. Arnstein Norheim.
Thank you. Good morning. Yes, thank you for the kind words. I'm here to give a brief introduction to what ZEG Power does and where we stand, our technology. Our mantra is more energy, less emission. We have a technology for highly efficient co-production of electric power and hydrogen from any hydrocarbon gas, including CO2 capture. We do this by combining two core subsystems, a modified reforming system and solid oxide fuel cells. We do this by introducing steam and fuel into a reformer operating around 600 degrees, where the steam methane reforming reactions and the water gas shift reactions occur simultaneously. And we also introduce a solid calcium-based sorbent, thereby capturing the produced CO2 and leaving us with a close to pure hydrogen stream out of the reformer. This close to pure hydrogen stream is fed to a solid oxide fuel cell module, producing power, and also only using part of the hydrogen for power production, so we deliver also surplus hydrogen. The surplus heat from the solid oxide fuel cell module is then fed back to a second reactor in the reforming system, where the calcium based sorbent, which has captured the CO2, is heated up to around 850, and the CO2 is liberated from the calcium carbonate, and then the sorbent is then regenerated and can go back to the reformer to produce or to capture more CO2. That's technology in brief. We have a very nice short movie that further explains our technology, and I'm going to show it to you now.
What if the world was clean? No air pollution from traffic or power plants. No release of greenhouse gases to the atmosphere. What if we could significantly decrease our use of fossil fuels, increasing the lifespan of our fossil energy reserves and make more of them available for future generations? A technology is now emerging that can help to do all of these things. It is called ZEG Power, Zero Emission Gas Power. It's a new kind of power plant able to run on various fossil and non-fossil carbon-based fuels. Vastly superior to the conventional coal or gas-based power plants we use today. Electricity and hydrogen is produced at significantly higher efficiencies while capturing carbon at the same time, leaving no emissions of CO2 or other harmful substances. ZEG is based on two types of technologies: the solid oxide fuel cell and a special kind of reactor. The reactor is fed fuel gas and water and produces hydrogen, while at the same time capturing CO2. Part of the hydrogen is then used by the fuel cell, which produces electricity and high-quality heat. This heat is delivered to the reactor that as a consequence releases its captured CO2 in a separate pure stream ready for storage. These two technologies enhance each other in their close integration, making them highly efficient. ZEG power plants can be built in various sizes, from your average gas station to large and centralized units. In addition to delivering clean electricity, the hydrogen produced could power your car, eliminating hazardous transport emissions. The world can be clean. And ZEG Power is leading the way.
So, what is ZEG Power? What is our technology? We claim that it represents a more sustainable use of fossil energy sources. Since we have a very high efficiency of our system, up to 80% is possible and above, we increase the lifespan of the fossil reserves. We don't release greenhouse gases. CO2 is captured as an inherent process of our concept. It does not come at additional cost, and it does not decrease the efficiency of our system. So we have sustainable solutions for an increasing energy demand. We have a lot of different market possibilities. I will come back to that later, and we will develop our technology together with the market. The company itself was established in 2008 as a joint venture between two research institutes, an Institute for Energy Technology outside Oslo and Christian Michelsen Research in Bergen on the west coast of Norway. Our business objective is to design, engineer, and verify our patented zero-emission gas technology. We will take it forward to commercializations, and our deliveries will in an early phase be to engineer and build and possibly operate plants, but as the plant size goes up, we will be more engineering office. The technology as such has been developed over the last 14, 15 years. Even before the company was established, and the two research institutes developed the technology. We had an early phase demonstration a couple of years ago on our 1+1 power plus hydrogen production facility on the west coast of Norway. Those results were very positive with respect to the technology, the efficiency, and the cost of the complete plant, but it was a bit too small to verify the thermal integration and the highest potential of efficiency we have. We have also done large-scale simulations within the company. We have done our own AspenTech HYSYS simulations for various large-scale cases. All with 400 megawatt power production, but with varying hydrogen production. But as you see, our results indicate efficiency around between 75 and 80%, regardless of the configuration. The interesting thing is that the pure power concept, the 400 megawatt L concept, is verified by Statoil's own Aspen Plus simulations. So the concept and the modeling behind is quite robust. So we can deliver around 75% efficiency, including CO2 capture and pressurization of the CO2 ready for storage. And then you can compare that to other technologies, and we are quite high on efficiency. Also, we have done a large-scale techno-economic study indicating that mainly due to our high efficiency, we have a positive net present value for our technology on large scale. And you don't have to, you should not focus too much on the absolute figures, but compared to combined cycle plants with CO2 capture, which will most likely never be economic feasible, our technology has the potential of becoming very economically feasible in the future. What we did in 2013 was quite a busy year for us. We engineered, constructed, and pre-commissioned a 50 kilowatt pilot plant. It's a plant with capacity of 20 kilowatt power and 30 kilowatt hydrogen, which approximates to 1 kilo per hour. I will come back to that. It's the ZEG project. We also had a third-party assessment from a German institute called ZSW that verified our technology. And we started pre-engineering of the next plant, a 10-time upscale from the ZEG plant, a 400 kilowatt ZEG plant. And we also filed new patent applications. The 50 kilowatt ZEG plant is our proof of concept pilot. It's based on the fuel is upgraded landfill gas, a kind of biogas. The objective of the project is to demonstrate and verify the efficiency potential of our technology by the close thermal integration of the solid oxide fuel cell module and the reformer system. We aim at 70% total efficiency, and we will do that while simultaneously capturing the CO2. The ZEG plant is placed within the Heino-Lillestrøm hydrogen refueling station. This was shown yesterday too. We have a commercial hydrogen production facility here with a dispenser. But inside this process hall, we have several hydrogen technologies that are demonstrated, among others ours. This is a picture of the reactor system, the absorption enhanced steam methane reformer system, with a capacity of 10 normal cubic meter hydrogen per hour installed within the facility. And here is some pictures from the 20 kilowatt SFC module. We decided to buy the stacks from an Austrian-German consortium led by Planze and Fraunhofer. These are the most open source SFC stacks that are available. They are well proven, well tested, and we are quite confident on the technology. We have 24 of these stacks in the module. They are configured in a dual stack box setup. There are 2 stacks within each of these boxes, and we have then 12 boxes to make up this SFC module. The rightmost picture is a picture of the complete module before it was insulated and installed at the facility. This picture really doesn't show too much, but it is the complete plant with the reforming section and the SFC module. Reformer, regenerator, and the SFC module here. So the test campaign, which will start right after Easter, the aim of it is mainly to establish operational knowledge on a close to industrially relevant SFC module. We will also focus on maximizing the efficiency of the system. We have a target of 70%, as I said, but we believe we have some margins to work with. But also we need to demonstrate and study the long-term operational flexibility and the long-term operational stability of our core technologies. This will then form a basis for further technology development and to make more commercial available plants. Another topic was studied last year was that we did, or we didn't do, the German institute ZSW did a third-party assessment of our technology. And one of the most positive conclusions were they did not identify any clear showstoppers. the challenges and the risks are already addressed within the company in ongoing projects and development studies. So this was a very nice tap on the back for us. Our next step is to pre-engineer and cost estimate the next plant. It's around 400 kilowatt plant, 200 kilowatt hydrogen production and 200 kilowatt power production. We will do some further technology developments within this plant, and we will aim at an even higher efficiency than we do at the ZEG project. So this will be a further optimized plant, giving us the 80% efficiency that we aim at. We have not decided where to build this plant. We are in discussions with the test center at Mongstad in Norway on the refinery there, but these things are not decided. We will pre-engineer and cost estimate this year, and then we will decide, hopefully early next year, what is the way forward. So our market opportunity is obviously it is the high efficiency, and which comes with CO2 capture included from fossil sources. We have the flexibility to use a wide range of fuel sources. As long as it has carbon and hydrogen within it, it's more or less okay. We can vary the product composition. We can design plants for only power production or combinations of hydrogen and power productions, and also possibly heat. And it is a scalable technology. The SOFC technology is scalable, and the reforming technology is scalable and modular. So our long-term goal is large-scale power production, but we see different market opportunities before that. ZEG concepts of varying size, producing standalone hydrogen and power, for example, for refueling stations. We have possibilities to integrate our technology in other industrial processes, and also for offshore applications. So I think the opportunities are it's a vast amount of opportunities for us. So, but we are still in an immature market. That is one benefit of that, is that we can grow with our markets. But we are working quite a lot at the moment to identify areas and possible industrial actors that can be good partners for us. We are doing a lot of case and feasibility studies for varying applications. Standalone production, as I said, integrated industrial solutions, and of course pure power production. Where are we in 3 years? Our target is to have a commercial product, a ZEG 200 kilowatt commercial product, which will be 100 kilowatt power production and 100 kilowatt hydrogen production, or somewhere in the vicinity of that. We also aim at successfully demonstrating and operating the 400 kilowatt plant by 2017, and we aim at demonstrating all the critical elements that needs to be further developed in our technology. And obviously we work a lot on reducing the cost, both with our suppliers but also what we do internally in ZEG Power. So the possible partner configuration is, of course, we need project support for our ongoing project, and new projects mainly. but also to do specific feasibility studies with industrial partners is of great importance for us. And also, we would like some direct investment partners too. So if there are any, please come to booth D62. So that was what I was planning to tell in public, and I would be happy to answer questions. And of course, you're very welcome to address me after this session, and also to come to booth D62. Thank you.
Thank you very much. Thank you very much, Dr. Norheim, for this wonderful presentation. Very interesting. Are there any questions from your side? So just raise your hand. We'll be with the microphone right with you. If I may start with my first question, Dr. Norheim. As I understood, it's solid oxide electrolyzers, what you're doing. Is that correct?
No, it's solid oxide fuel cells.
Solid oxide fuel cells?
Yeah, because the hydrogen is produced by a modified steam reformer.
Okay.
So we don't consume electricity. We produce electricity.
You produce the electricity. Okay, very good. So you need at high temperatures, like 950 degrees, as you said?
Well, we need a temperature gradient in our system, so we need our peak temperature above the regeneration temperature of the CO2 sorbent. Yeah. And we regenerate at around 850, 860 somewhere. So the peak temperature needs to be higher than that.
So did you solve all the problems with the materials, because the materials also have to cope with these high temperatures?
No, I don't think we have solved all the problems at all, but we have solved enough problems to be able to build this pilot plant, and we will most likely experience new challenges and problems when we operate it over a long time, but we have solved what is needed to build this plant.
And my second question is, you say CO2 capture is one of your targets. What will you do with the CO2? I know in Norway there's some projects going on to get the CO2 into the ocean back, but is that a possibility?
That is a possibility, because included in our system modeling, we dry and compress the CO2 ready for storage. So if there is a storage infrastructure, we can deliver directly to that. Do you
have already storage places in Norway for CO2?
Not available for us, but there is a long time ongoing project, or there is storage in the North Sea. Statoil has been storing since the mid-90s. Right. But it's not an infrastructure going into onshore, so we don't have the infrastructure yet. Okay. No. But we are also working on side projects of utilizing the captured CO2 in other processes. So we're not totally dependent on the CO2 infrastructure. No.
Thank you very much. Are there any more questions from your side to Dr. Norheim? So I would like to thank him very much for his presentation and for taking the questions. Thank you very much. This is your applause.
Thank you.
Ladies and gentlemen, in 5 minutes' time, we have the second presentation here on the stage of the Technical Forum, which will be given by Dr. Guttorm Syvertsen-Vik. He's Product Manager of Serpotec AS, and he will talk about impact of raw material quality on performance in energy applications. We will start in 5 minutes' time. Thank you very much.